00 cold open. In the last video we went through the instrument itself, the dial, the yellow button, the 4 checks and the safety rules that keep the meter and your hands intact. Now we use it, 11 measurements in order exactly how you actually perform them on the bench. If you have not seen part 1, the link is below, because from here on I am assuming you know which jack the red lead belongs in. One reminder before we start, and it is the one that matters most. Before every single measurement, inspect the leads, choose the right jack, set the function, and connect COM first. 10 seconds every time. 0, 1. 11 measurements start to finish. Now the practical part. 11 measurements, exactly how you actually perform them. 1. Mains AC voltage. Red lead in V ohm, black in COM. Dial to AC volts. Probes onto line and neutral, minding your clearance and your insulation. You should see roughly 230 volts. Press yellow and you get the frequency instead, roughly 50 Hz. True RMS gives you the correct effective value even when the waveform is distorted. 2. 12 volts DC red in V ohm, black in COM. Dial to DC volts, red on positive, black on negative. Roughly 12.0 volts. If you reverse the probes, you get the same number with a minus sign. No harm done, and that is genuinely useful for identifying polarity on an unmarked connector. 3. 100 mV DC same leads. Dial to millivolts DC. Consider selecting the range manually here for better resolution. You should read about 0.100 volts. This is the mode for sensor outputs and for measuring across a shunt to get current without breaking the circuit. 4. A 10 kilo ohm resistor power off and ideally lift the component out of the circuit. Red in V ohm, black in COM, dial to ohms. Probes across the resistor, about 10.0 kilo ohms, while lifted out, because in circuit everything parallel to that resistor is measured along with it. You will read low and blame the wrong part. 5. A 220 microfarad electrolytic capacitor. Discharge it first, completely. Dial to ohms, then press yellow to reach capacitance, probes on the terminals. You should read around 220 microfarads. That part is specified at plus or minus 20%. So anything from 176 to 264 microfarads is within tolerance. Below that range, the cap is drying out and it is on its way out of the circuit. 6. A 1N4001 diode. Power off. Dial to continuity, press yellow for diode test. Forward. Red on the anode, black on the cathode. You should see roughly 0.6 to 0.8 volts. That is the forward voltage drop of the junction. Reverse. Swap the probes. You should see OL. Over limit. No conduction. 0.6 one way, OL the other way. That diode is good. Any other combination and it is not. 7. An NPN transistor. ABC547 or BC546. Power off and ideally desoldered. Stay in diode test mode. Base to emitter, red on base, black on emitter. Roughly 0.6 to 0.7 volts. Base to collector, red on base, black on collector. Same again, roughly 0.6 to 0.7. Collector to emitter, both directions. Should read OL. No path because there is no base current flowing. That checks both PN junctions, which catches the vast majority of dead transistors. It does not verify gain, so for a full functional check, you still want an HFE measurement. 8. Continuity. Dial to the continuity position. Probe both ends of the conductor. A beep means a good connection. Silence means a break. This is the fastest fault finding tool you own. Fuses, cable looms, switches, connectors, broken traces on a board. Start here. Always. 9. Temperature plug the type K thermocouple into the meter. Set the dial to the millivolt and temperature position. The yellow button toggles between Celsius and Fahrenheit. One warning, never attach a thermocouple to a live circuit. The probe tip is conductive and it is not insulated for that. 10. DC current up to 400 milliamps. Red lead into the milliamp jack, black into COM. Power down the circuit, break it and insert the meter in series. Dial to milliamps, read the value. Do not use the 10 amp jack for this. You lose resolution for no reason. 11. DC current up to 10 amps, red lead into the 10 amp jack, black into COM. Same procedure, circuit open, meter in series, dial to amps. Take the reading quickly, then remove the meter. That jack is intended for short duration measurements and never ever push more than 400 milliamps through the milliamp jack. Different jack, different fuse, different rating. A C current works exactly the same way. Same jacks, same series connection, just the AC range, and True RMS handles the waveform for you. 02. The fault table. 4 readings and what they tell you. Resistance shows open circuit. The component is open or you are out of range. Check your range first, then condemn the part. A diode reads near 0 volts in both directions. That diode is shorted. This is one of the most common failures in any power supply and it is a 30-second check. A transistor shows no conduction from base to emitter and none from base to collector. Both junctions are gone. That part is dead. And an AC reading that looks strange on a cheap meter. Before you tear anything apart, verify it with a True RMS meter. There is a very good chance the meter is lying and the circuit is fine. 03. Close 11 measurements. Voltage, millivolts, resistance, capacitance, diodes, transistor junctions, continuity, temperature and current in both ranges. That is the whole instrument working for you. And notice how much of it is fault finding rather than measuring. A capacitor that reads low, a diode that conducts both ways, a junction that has gone open. Those are answers and they take seconds once you know where to turn the dial. The workflow never changes. Check your leads, choose the right jack, set the function, COM first. Measure. Remove the leads, power down. Do that consistently and your meter will outlive several of the devices you use it on. Thanks for watching both parts. A like and a subscribe help more than you would think. There is more of this on the channel. We take dead electronics and we find out why. Because it is not dead yet.